Yes, we've got this. A problem-solving plan. Okay, guys, the gray box has what they refer to as the problem-solving plan. Step 1 is read. And if reading doesn't help, read it again. Figure out what they want. Okay? Step 2, ascribe to it a variable. Like I said, use Q. It always tricks people up. Okay, step 3, reread and establish an equation that seems to represent what you're dealing with. You got to represent, folks. Solve, and that's, solve numerically. You're looking for answers if possible. Step 5, this is the one people rarely seem to utilize, and it is the most helpful. Check. Does it make sense? Okay, if not, start over. For example, the bridge is 2 years older than the road. Bridge is 2 years older than the road. The road is 10. How old is the bridge? If you tell me -8, then it's a time travel bridge, and we need to talk about physics class.
I love that.
So make sure that the numeric value, while you might be right numerically with whatever you did, it certainly doesn't make sense for something to be -8 years old, okay? So think about your answer and verify that it makes sense, okay? I am never going to say to you, solve using the 5-step plan, in that I want you to chart it out, because I believe several of us use the 5-step plan maybe in 2 steps or maybe in 3 steps, all right? This is a guide. I am telling you that you may find your own thinking way. It might not be this grammatically this way, okay? So that being said, when it says solve using the 5 steps, I am basically looking for, what do I want? I want your equation and I want your answer. Okay? If all I see is an answer, I'm going to assume that you copied it, because there's no way for most of these, with the exception of the bridge story, that you could do this without thinking, okay? If you're a drawer, draw the boxes, draw the chart. I don't care, okay? So here it is. Wow. The first example they give us is like ridiculous. Okay, here's the example I'm going to give you. Here we go. All right. A puppy, yep, weighs 12 pounds more than a kitten. As a matter of fact, the puppy weighs 7 times what kitten weighs. Okay, so it looks like we have some information. We have weight. We have puppy. And we have kitten. And this is one of those scenarios where you're thinking to yourself, wait a second. I only know that in comparison to kitten, puppy is 12 pounds more, and I know that puppy is 7 times what kitten is. Okay? Since both of these two phrases refer to puppy, and obviously puppy is puppy, they equal one another, which now looks like this. Okay? K plus 12 equals 7K. K plus 12 equals 7K. I am going to subtract K, and gets me 12 equals 6K. Does everybody see that I just subtracted K here? Okay. 12 equals 6K. That means K is equal to 2, right? So it looks to me like kitten weighs 2 pounds. Oh, I never did ask you what I wanted. What is kitten? I'm copying it and I'm trying to shorten it. I apologize. What's puppy? So if kitten's 2 pounds, what would you estimate puppy to be? Go ahead. Which is? Okay, to check to make sure you're right, is 7 times 2 also 14? If not, something's wrong. Okay? They're not all going to be quite that easy, unfortunately. Okay, and in this assignment, they're going to give you choices. If you want to use your choices, great. If you just want to solve for your answer, that's fine too. All right, I don't care. Most of you are advanced enough to want to just solve it, but if you don't want to, that's fine. Okay. Here's my next example, and I know the book only gave you one, but they're all different, and you really, really are going to feel like a fish out of water at first. So here's my example 2. J has 1 1/2 times as many books as Ray. Together, they have, lost my place, 45. Question is, how many books do each of them have? If I were to chart it, I would be recognizing that we're counting books. Ray and Jay. I don't know much about Ray, but I do know that J is 1 1/2 times. Now you can either go this, or you can go like this. Both of these things mean the same thing. Now I'm going to show you that this might be easier. But if you don't like that, that's fine. Together, they have 45, which means Ray plus J is 45. If Ray is R and J is 3/2 R, I can find my answer. Now, because I've chosen to do fractions, I need to make 1 R into a fraction, which sounds to me like it'll be 2/2. Are you tracking with me over here? An improper fraction, meaning 1, has to have the same denominator. Since we're combining these, it is 5/2 R equals 45. Or it would be 2.5 R equals 45. Okay? If you were using the 1.5, at this point you would divide by 1.5. I chose the fraction though because you can't divide by a fraction, you must multiply by its reciprocal. Now remember how I said this way is easier? It's because you don't need a calculator. 45 divided by 1.5, most of you are going to go boop, 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 and get your answer. But if you don't have a calculator and you think fractionally, you can hope that the yahoos that wrote the textbook thought fractionally as well, and in this case they did. Looks like R is equal to 18, am I right? if that's correct, that's Ray. I can find J by subtracting total minus Ray, right? I can do that. Or I can take this and multiply it by that. 18 times 1.5 happens to be 27, the sum of which indeed is 45, which checks out. Okay? Fractional thinking really, really can be helpful. I promise you, it's extremely helpful. Okay. All right, one more. The garage, sometimes garages are built after a house, is 21 years newer than, sorry, some of you can't read cursive, the house. The garage is 21 years newer than the house. The garage is also 1/4 as old as the house. This is one of those problems where I oftentimes have to take a real world scenario and describe it to myself. If you don't need to, that's fine, but I sometimes do. So let's see if I can figure it out this time. Looks like we're comparing ages of garage and house. We don't know nothing about house, so we're going to call house that age. If the garage is newer, that means it's younger, right? Like you all are newer than me by whatever amount. Which means house's number has to be bigger than garage's number with respect to age by 21 years. How can I show that house is bigger than garage by 21? Bravo. H minus 21. We also know that the garage is 1/4 the age of house. Oh, another fractional one? 1/4 house is 1/4 house. Since both of these descriptors are describing garage, and there's only one of them, they equal one another. Okay? Which means we have this equation. By the way, I hate this kind. I'm going to tell you why. You certainly aren't going to work with a negative year. Maybe you will. I wouldn't. So I am going to gather my H's on the left, as such, and bring my 21 to the right. You could actually work it this way, because when you divide, you would have ended up with a positive result. Anyway, 3/4 H is 21. 3/4 H. Can't divide by a fraction, so we are going to multiply by the reciprocal. Oh, look, the people who wrote the book thought about fractions. Looks like house is 28. Would you all agree with me? What if I came up with 20 here? 20. And you might say, well, 20 is fine, and 1/4 of 20 is 5, no problem. Why would 20 cause a stir? Look at this. Then if I had 20, 20 minus 21 is -1. House cannot be -1 year old, or garage cannot be -1 year old, okay? So if house is 28, 1/4 of 28 is 7, which is also the result of 28 minus 21. By verifying that, I am able to obtain that I have done this correctly. 28 minus 21 is the same as 1/4 of 28. You could check yourself that way. Yes, sir. Did you do garage and garage plus 21? And 3/4?
21 times 4. And 21 is 1/4 of the house.
Yep.
And that equals 84.
Yep.
So I minus 21, that's 63.
Okay.
So I came up with garage is 63, and the house is 84. And then I tried dividing these stuff and so on.
Okay, interesting. So that is another number that could work. Excellent. I wouldn't mark you wrong for that. There's a lot of combination of numbers where one of them is different from the other by 21 and can be thought of as 1/4 of it. Yep. Yeah. You know what though? In this assignment, there's options. So unfortunately for you, you'd have been like, oh, well that obviously is wrong. And you might have had to come to me and I might have had to say, well, your answer is technically right, but this is what they were looking for.